by measuring the force required to stretch a rubber band 1 centimeter, 2 centimeters, 3, 4, and so forth. We take measurements at 1 centimeter. Actually, we took measurements at 5 Newton intervals, 0.5 Newton intervals, so that on a force versus stretch, X represents a stretch in centimeters. We have a point. 1 centimeter took 0.5 newtons. 2 centimeters took 1 newton. 3 centimeters took 1.5 newtons. This looks like it's going to be a pattern. However, to get 2 newtons, we had to go all the way out to a stretch of 4.5 centimeters, not 4 centimeters, which would have followed this pattern. And then we had to go all the way out to 6.5 centimeters to get 2.5 newtons. So we see that the slope of this graph is decreasing. The effective force constant is obviously not constant. Calculating the areas under the graph, we obtain 0.25 Newton centimeters here, 0.75 Newton centimeters, 1.25 Newton centimeters, and 1.7 Newton centimeters. Again, each area is simply the width of the trapezoid multiplied by its average altitude. Now these trapezoids are 1 centimeter wide. Okay, so we're making trapezoids at 1 centimeter. We don't really have a data point for 4 centimeters. It comes out here at 4.5 centimeters. And the graph really isn't drawn very well here, but it's supposed to be at 4.5 centimeters. So we're going to have to estimate from the trend of the curve just what the forces would be here, and of course we do have a measured force here. So there's some estimation involved, but these are reasonable estimates of the areas. And I believe we figured one more area. I think we figured an area of 1.95 here, and it's not indicated on the graph, and we didn't bother figuring this area. We can come over here and make a table. Okay, just to focus on what the table's telling us. X is going to be the stretch in centimeters, 1, 2, 3, 4, 5 centimeters. Work is going to be measured in Newton centimeters. That's not the standard unit of work, but that's the unit that makes a certain amount of sense in this case. We will standardize those units shortly. This column is going to be the work done during the last centimeter, the change in the total amount of work corresponding to the last centimeter. So for example, at 1 centimeter, the last centimeter went from 0 to 1 centimeter. For 2 centimeters, the last centimeter went from 1 to 2 centimeters. And we've seen that the areas which correspond to the work contributions are 0.25, 0.75, 1.25, 1.7, and 1.95 newtons. The total work from 0 to X, from 0 to 1 centimeter, well, it's just 0.25 Newton centimeters. From 0 to 2 centimeters, out to 2 centimeters, we're going to have to add the work from 0 to 1 to the work from 1 to 2. Got some feedback. Let me tone that down. Excuse me. And we're going to get 1.0, the 0.25 and the 0.75. Similarly, from 0 to 3 centimeters, we're going to add the 1.25 to what we had up to 2 centimeters. We're going to get 2.25. Up to 4 centimeters, adding the 1.7 to the total, we get 3.95. Adding the 1.95 to that, we get 5.9 Newton centimeters of work to each of those points there. We have a table that gives us the work to the point versus the position of the point.